Thank you very much. It's a good tie-in to talk about some of the applications we're doing with what the Center for the Environment was just talking about. And it's a great opportunity to be here, and I figured it was appropriate since decided to talk about grand challenges to put a picture of the Grand Canyon there for reference to give the appropriate perspective on things. But let's see. Okay, assuming I can get this to work. There we go. So in talking about grand challenges and policy and global issues, one of the things I decided not to put up here about the work that we're doing, I tried to talk about more global problems and the work we're doing specifically related to policy, but if you're interested in that, I'd be more than happy to point you at some recent work that some of our faculty did. We ran a workshop at University of Victoria where we were talking about basically visualization and analytics for global policy and policy decision makers, having a lot of people from the Prime Minister's office of the Canadian government there, researchers from across North America talking about the role of visualization and data analytics for data-driven policy development, which is another interesting talk I'd be more than happy to describe for you. But a lot of the things that I see that comes up really has to do with big data. And really, it's become the buzzword lately. If you search, you can find tons of conferences you can go to on talking about big data and what it can do for you. And really the question is this a solution for global challenges? And there's three interesting components in talking about big data, two of which I think affect most situations, but people sort of ignore. People always go at the volume or the size. We need to have exabytes. We need to have zettabytes of data before it's actually big data. But if you look at the velocity of the data and the variety of the data types, that's also two key components of how do we put this information together. And that's really where our team has focused most of the research that we're doing, is in determining how we can actually help solve those problems. We do handle very large-scale data sets as well. But our goal is really not sort of what is the data, but how can we help people become more effective and more efficient through harnessing that amount of information that's out there. So we really look at the issues of how do we deal with heterogeneous data? How do we deal with multivariate, multidimensional data coming in different forms of media? How do we integrate all of that together when there's conflicting data, when there's confidence issues with the data? You have categorical data, you have temporal evolving data. You're trying to put all of this together and saying, what is the correct what is the answer to the problem I'm trying to solve right now? And a big problem with this that we deal with both when we're talking about public safety and science challenges is the scales of the problem sets. That you're getting data in that is at multiple scales, you're dealing with cross-scale solutions, and it becomes very hard for humans to reason across multiple natural scales. And that's where visualization can really be a big problem. So I don't believe that big data analytics is the solution. IBM may have a different view in their marketing information, but what we really do is we look at how can we get beyond just applying automated techniques and include the human in the loop to really solve this. Advanced data analytics can help you, but there's a lot of things that it falls short in, and that's dealing with these types of data where you're mixing things with multiple types of categorical, nominal, preference data, fuzzy data, uncertain information, and you're trying to reason across this and trying to incorporate it and provide someone the appropriate context for making the decision that they're looking at. And you know, the thing that we always run up against is no matter what your source is, you never have all the data, right? The data is never complete. It's never perfectly accurate. There's a lot of other information that goes into decision making that never makes it into the underlying data. And we run into this all the time. And that's where the human in the loop becomes so effective. So really, what we look at is how do we handle this multi-parameter large data with incomplete information to help people make their decisions more effectively. And I see this cutting across multiple global challenges. And we really look at how we can bring visualization and integrated analytics and interaction in to help people solve this. So can we transform all of this data and information into actionable knowledge for decision making? And visualization is really a key method for doing this. it also has its problems. People believe what you put and their eyes tell them. So you have to make sure that, as one admiral put it, it's a very useful tool, but it's a very dangerous tool. It can give him very good insight if he understands the data and what it's telling him. If someone doesn't take the time to do that, they can quickly be misled, where if you provide them with other types of data in numerical form and they have to perform analysis on it, they won't be misled as likely. But they probably won't take the time to actually do the analysis. So you've got that trade-off there. So we really try to look at how we can help people make appropriate visualizations and come up with information so that it's more accurate for what they're doing. And that's where visual analytics comes into play, where we're really combining in human decision making in an interactive environment through a graphical front end to help people make more sense of their data. And that's what our center is about. And so for big data, our solution to solve most of these problems is to help and pull out the relevant information needed to answer the question at hand in the time that you have to make the decision and take the action that you need to do it. So this is where the user guidance is key to the process, and we adapt it to whatever environment you're in. If you're out in the field collecting data, or if you're an emergency responder, you have 5 seconds to make a decision. What information can we provide to you that will help you make the decision? If you're someone who's studying a problem and it takes 6 months for your data simulation to run, what can we do to help you understand that or decrease the time that you wait before you get the answer and realize that it's wrong? And you need to change parameters and start your simulation over again. So we look at all of those different avenues of different modalities, from cell phones to running on big iron applications. And so I think it has a lot of advantages. We're working at a lot of ways, instead of just this idea of helping decision makers, to also communicating information and allowing people know the reasoning behind the information. And with all of this work, we really focus on how the end user can solve the problem. Really, what is the problem someone's trying to solve? How do we engage them from the beginning? We never start a project without having a partner or client, depending on what you want to call them. So we start with people with real-world problems, and there's a commonality of the problems that we work on that really is quite international in its scope. And I'll give you a couple example problem areas that we've been working on, talking about some very localized data relating to climate, the question of when will you get precipitation out of a cloud. That's very important to understanding droughts, floods, and localized climate information. I'll talk about issues in critical infrastructure, some public safety work that we've been doing, and the idea of risk-based decision making. How can we become and incorporate risk measures into decision making for people at multiple levels within an organization? And so the first example that I'll go over is ties very well into the issue that we were just saw as an example from the Climate Center, and that's dealing with this problem of measuring the atmosphere and trying to answer the questions from a combination of simulation data, from measured data, that we're actually trying to bring data in from simulations and from observations that are across a multitude of spatial scales, a multitude of temporal scales, and there's no sensing equipment currently that can pull all of the data and provide it in a uniform platform. So some of the examples of the data sets that Dr. Sonia Lasher-Trapp from Earth and Atmospheric Science is pulling together includes flying instruments in aircraft through storms and through cumulus clouds, measuring things at 1 millimeter at 10 kilohertz, going up to interactive high-resolution Doppler experimental radar that's 1 kilometer resolution and takes 5 minutes per sweep. How do we integrate across that? At the smaller than 1 millimeter resolution, we're incorporating simulation data, and all of this is being put together to try to understand these two clouds that look very similar. This one produces rain or ice, this one produces nothing. What's going on with the entrainment of air and the processes within the cloud that will actually affect how much precipitation goes into the given location. And so that's why in her view, you really need an interactive visual environment to solve that problem. You need to look at multiple ways of representing 1D, 2D, 3D spatially evolving data to study the problem and integrate it together. And this is a case that is problems that they've looked at regionally within the Midwest. They've looked at issues down in the Caribbean and in the UK as well. She's actually going to be spending 2 months this summer studying cumulus clouds in the UK. I haven't offered to go and help her on that experiment when she was down in Antigua for a month in February a couple years ago. I thought she needed real-time visualization support for her work, but the UK will be nice this summer, but not quite as attractive. And so we look at a bunch of different ways that to try to pull this information together and help her understand the super icing effects that they're actually starting to prove that are occurring in these clouds in a new process going in it. And this is really a case of starting at the microclimate model, then going up to the mesoscale and synoptic scale of cloud modeling, which most of the things that are being studied here never actually make it into the global climate models because it's too small of a resolution to be modeled. It's just a parameter or a constant that gets added into the global climate models because they can't simulate it well. So if you get better models here, you'll get more accurate localized global climate models. And another issue we've been doing I picked things that I thought would give a wide range of the applications that we work on, is a problem dealing with cascading critical infrastructure. The entire world's dealing with critical infrastructure that's aging and never gets the money and support to repair it. And all of these systems are intertwined. Trying to maintain and understand and increase the reliability of a given infrastructure is a challenging problem. But now that they're interlinked, how do people actually come up with a way to understand the roles of these? What is the role of power supply, computer networks to controlling the power grid, and power grid to supply the controllers of the computer networks that control the power grid, looking at transportation, food supply, weather, severe storm implication on this. We're actually working on a project that's joint between the German BMBF and US DHS, looking at these linkages between the different infrastructures. And so it really does mean integrating data from a lot of different sources, bringing in industry, bringing in government decision makers, bringing in experts in the different areas to pull this together. And the scenarios we're looking at are the effect of severe storms in Germany on the power grid and the smart grid technology that they're developing there, as well as looking at severe weather and hurricanes to the food supply in North America and the relationship of taking down power systems that feed into the processing facility or cut off roadways, either multiple effects for food supply for quick service restaurants. As things become more efficient in our global economy, you have the problem that when a truck goes to deliver product to a restaurant, it only knows the next stop it's going to with the refrigerated content on the back. Dynamic real-time optimization is done on the life expectancy of the product based on the temperature conditions that are monitored. And after they deliver here, it's re-optimized and they're told where to go next. If the transportation routes are hurt, or you actually have a disconnect or a computer network goes down, all these trucks that are carrying frozen meat to all these restaurants just pull off to the side of the road and wait to be told where to go next as the product is spoiling. So this is an interesting problem, and the food service industry is one of those things that you never really want to know. If you get a hamburger in a fast service restaurant, the ingredients actually come from 183 different countries. Okay, if we're looking at quick service restaurant production of frozen chicken and distribution in Germany, actually all the poultry is coming from Thailand. So understanding the role of all of these different factors is quite interesting. So this is just a couple examples we're looking at there. We are also doing work in public safety from trying to increase the efficiency and effectiveness of law enforcement agencies at the local, state, and national level. One of the applications we've been looking at is crime analytics and predictive crime analytics, working with regional local and regional law enforcement agencies here in Indiana, as well as interest in this project from the state police in Sao Paulo, Brazil, as well as some of our Canadian counterparts. So there's common problems that affect the entire globe, and we're looking at ways to see how we can help people become more effective with this. And this is the type of thing that we produce, where it's a completely interactive system integrating multiple components of data. You can see the localized hotspots of crime activity. You can see the time series variation of that. You can see the time of day variation. You can look at a calendar view, so you can see, is there a day of week effect or weekly variation that you're seeing? And we can also pull into this the ability to scale through and look at any portion in time, as well as incorporate real-time anomaly detection in Twitter data, so that you can see, relating to the crimes that are going on, what's going on with social media now. And so through all of these windows, you can actually go ahead and select which portion of the data you want. Do you want to know what's going on with a certain category of crime on Friday between 5 and 9 p.m.? We can pull that in. We can pull in multiple sources of data relating to weather information. In this data, we've also looked at bringing in EMS runs to reduce high-risk alcohol behavior on campus, where we're looking at the relationship of football games, home and away games, the outcome of the games, looking at violations in dormitories, looking at EMS runs and the outcome of whether the people were treated and released, taken to the hospital, or sent to jail, as well as the law enforcement data. And this was a multi-agency project within campus trying to increase the wellness of students, because as John Cox, our Purdue police chief, says, his goal is not to not put people in jail, it's to return the children safely to their parents after they graduate. And so that's really the motivation of what's going on here. But this was just one example of integrating multiple sets of data. And as I said, our colleagues right now, there's a workshop going on between Purdue Engineering and some groups in Brazil that I'm here instead of being there right now. But one of the things that our collaborators down there are interested in is understanding crime and trying to get a handle on their crime with the upcoming World Cup and then the upcoming Olympics. They have a serious crime problem with the influx of targets of opportunity. They're very interested in using some of these predictive capabilities. We're also talking to the NYPD and about to sign an MOU, because while they've done a great job improving the safety of the city, they have very, very little analytics involved in their crime prevention right now. So we're pulling all of this in. We're also helping with the gang problem. We have a tool that does real-time location tracking and some interpretation of gang symbols when you take a picture of gang tags with a cell phone. This has been deployed to over 72 officers within Indiana, and we've had several thousand images uploaded. We also take in tattoo data from the Department of Corrections. We have not gone beyond Indiana because we cannot verify law enforcement officers' credentials outside of the state, but the Indiana State Police has taken over the server yesterday, and they've agreed that if people join the Indiana Gang Intelligence Network, any law enforcement officer across the country can now get access to this and contribute data. We're setting up a parallel database with Cook County, Illinois. We have an MOU that's been signed with the Illinois State Police, and we're also doing this on the Navajo Nation in New Mexico. But when a website recently put up that this was going to be released outside of Indiana, a Facebook page called Cop Apps, we had over 50 requests from across the country from law enforcement officers wanting this. This is a national problem. And the things that you're seeing in Indiana are gangs that started several years ago in Southern California. So we're trying to see how we can incorporate all these different sources of data. And the final thing I'll talk about very quickly is just the risk-based decision making. How can we bring in measures of risk and have people use data-driven and risk-based decision making? We've done a lot of work on this project, not only within the US, but with Canada and the UK. We've been working very closely with our partners in the US Coast Guard in terms of analyzing historical data, doing resource allocation and reallocation. And actually our software most recently was used in Superstorm Sandy in the response. The Coast Guard Atlantic Area Command used it to quickly determine what resources they would have to deploy to New York and New Jersey in response to it, based on the fact that so many stations were damaged, and now they're using it to prioritize and determine the level of rebuilding needed of those 14 Coast Guard stations that were damaged. So all of the inputs into that to that decision-making process are coming out of the software that we provided from them. And on maybe the 22nd of this month, it will finally be verified and validated for use by the Coast Guard system-wide. It was supposed to happen in February, that it would be signed off for official use. They've used it for decision-making quite a bit, but to get the official approvals, it was going to happen in February, but there was a sequestration process that's been causing me nightmares for the past several months, and lots of complications in what we do. But for them, it's even more serious, and they couldn't get an admiral to look at it. It was supposed to happen on the day of the Commandant State of the Coast Guard address that I was able to attend. But it looks like now on April 22nd, it'll be approved. So this is a case of where they're bringing in all these risk measures, they're looking at their performance, and they're actually trying to see how can we make more effective decisions. And you'll see that the tool looks very similar to our crime analytics software, which is why we're able to deliver to them. The problems are common across so many areas that we gave them a prototype once we got their data in 2 weeks of giving from when they gave us their data to the initial prototype. And so we've been able to help them, and Vice Admiral Parker is using this not only for these type of effects. This is showing the data for the Superstorm Sandy decisions that they were making, where were the cases, what were the types of cases that they were seeing. But he's also using it for his operational performance and assessment reports and his operational risk assessment model. He has it running on his iPad, and he finds that it's very effective to help him understand, are we gathering the right data, and do we have the right metrics for our operations, and not, are we hitting all the benchmarks and everything's green on the dashboard instead of red, but is this really helping us become more effective? And so that's where it's going up to the decision-making level and getting people who are actually questioning how the organizations run and are they doing things effectively, which is very interesting to see. So with this, hopefully I've shown you a couple examples that give you an idea of how integrated visualization can be applied to a lot of challenging problems. We're also doing work in cybersecurity and economic visualization and decision-making, and several other projects. So Soundscape Engineering Project, we're talking about how we can bring in visual analytics to apply to that domain. I had no idea that all of this data was available for so many years of accurate high-def sound recordings of the environment, but it's quite an interesting challenge. But just a way of, can we create more effective and efficient decision-making environment for people? And I think our keys to success are really that everything we do is user and problem-driven, and it's really trying to balance what humans are good at with what computers are good at, and making sure that it's easy to use and answers the questions that the people really have. And a key thing to this is, can people understand that number that comes out? There's these systems that'll take in all this data, do all this crunching, then tell you something's going to happen. If you don't understand why it says that's going to happen and it goes against your intuition, your cognitive bias comes into play and you're not likely to actually trust it. So how can we present reasonable and evidence for that decision making? So the final thing I'll just put up there is, if you'd like any more information, feel free to contact us. We're always looking for interesting, challenging problems. And the thing that I forgot to mention about the risk-based decision-making is we will be hosting here November 13th and 14th the Maritime Risk Symposium that will be looking at risk-based decision for the maritime domain. And we will have at least some 3 stars, if not the Commandant of the Coast Guard here as our keynote. He can't commit quite yet, but we have very good participation from, historically the symposium has been a partnership between a university and the Coast Guard. This year we're trying to get more Navy involvement into it and bring in issues relating to climate change and the relationship of that to the Arctic and shipping and maritime risk, as well as the droughts and navigability of the inland waterways in the U.S. If you look at issues that people are dealing with, the maritime transportation system is having terrible trouble given the fact that the low water levels from drought, where you have flooding issues, and you also have all this exploration going on in northern Alaska and new shipping routes, as well as having the wider Panama Canal coming into existence for larger ships. So there's a lot of changes going on relating to a lot of issues that we'll be talking about. So, thank you. Yes.
I don't know if this is a question or a comment or an observation or a suggestion. Maybe it's all of the above.
Okay.
I work in the electric industry, and your Coast Guard application here struck a chord with me. And at some point, you might want to try to link up with the Edison Electric Institute, which is sort of the policy group that kind of all the electric utilities fund, because they're not subject to the sequester. But one of the issues that we're struggling with as an industry is, given the essentiality of electric service now for communications and commerce and everything else, these multi-day outages and so forth just really, they're no longer tolerable. And we've had, 6 or 7 major events in the country over the last 2 or 3 years. Unfortunately, many of them in my service territory, which was no fun. One of the really powerful applications that we've been trying to do some work on with the University of Connecticut, but I don't think we've really got it cracked, but you've got more capability here, is to take kind of weather data and translate that into kind of predictive failures around the electric system, so that we can kind of pre-position crews that would allow us to kind of very quickly be able to go in and hit the trouble where we think we're going to have the most trouble spots. And one of the big issues that we're seeing, particularly with these major multi-service territory storms like Sandy and the hurricanes that have come up the eastern seaboard, is how does the industry allocate mutual aid crews? Because usually when a utility has a problem, crews come in from all over the country to help, and usually whoever screams the loudest gets the crews, which may or may not have anything to do with where the damage is going to be. And again, from a national, I know this approaches the level of national security, it probably does at some point, but certainly keeping the economy working and so forth, figuring out the right way to kind of allocate all these resources across that sector is turning out to be a really timely, important issue that nobody's really got a good way of solving, but this tool, or set of tools, is kind of perfect for trying to bring that into place.
I think that's very interesting. We're actually, hopefully we'll be starting a project. It was suggested by someone in operations research at the Atlantic Area Command to pull together, there's an ADCIRC model from the University of North Carolina, which is a storm surge model for hurricanes, and also the most accurate prediction of where there's going to be flooded and where there's going to be landfall, that a lot of people are switching over to. The Coast Guard's used it for the past 3 years for the hurricanes to decide where they're going. And it's very good at predicting the paths and the infrastructure that will be affected by it. Hook that in with a project at Stevens Institute, which really looks at, if you have a port closure, given the commodities that come into a port, what other ports could you reroute that cargo to of what's coming for the next 2 weeks? And then hooking a visual analytics front end into it to sort of guide and let the decision maker say, well, what is the scenario if we're going to do that? You could do something similar for the power distribution and crews of saying, where do we think the outages are going to be based on this current path, by bringing in that weather data. And you actually can get a lot of good data from what I'm told, anecdotally, is that if you go to a local power company's control center, you'll see which transformers have gone down and which lines have gone down on their portion that they control, so that when a tornado comes through Indiana, I was told by someone that they had seen a center where they could watch, where they lost power and where things were going down. And if they had to say, where did the tornado hit, they had to send out state police to find out where did it actually locate and where did it touch the ground, where they could actually get data from the power company to actually know where did they lose things. And as you get more smart grid technology, you can localize things much better and get an idea. So you can get that historical actual measurement data of how the infrastructure has been affected as something's moving through. So as it hits North Carolina, you can see, well, what might we be looking at for Virginia? What percentage of the power lines or transformers or what equipment are we going to need? Pull that in, bring that into the latest maybe European model based on the accuracy of the past few store forecasts versus the US track model, and look at reallocation. And I know maybe not in the power grid, the power industry, but if you look at Walmart, they actually do quite a bit of pre-positioning for these storms, because and some of the food quick service restaurants do this as well, in figuring out where can they get food to resupply as different things are going to go down. And so I know that during Katrina, they actually had mobile restaurants that were ready to be set up and provide food to emergency workers, et cetera, and the state police turned them away. And that Walmart had all these pre-positioned supplies that the local authorities wouldn't let the trucks through to get to resupply people. So that the companies had started hooking some of this together, and that, but it's that sharing of data, right? There's these different sources, and if our people are willing to come together in something like the Edison Institute and sort of, that's what I think the universities and these nonprofits can provide, is this idea of an unbiased, as was mentioned before, opinion-free approach to do this, where people are willing to share information that they might not with a competitor. Yes?
You put your finger on a very important aspect, and that is looking at the scenario of unfolding developments and linking that to protocols that are developed beforehand, so that you have pretty much the rules established, and the protocols, of course, link the various responding groups, as well as people that support the responding groups. And in many cases, the protocols are missing. The other issue is that as far as these visual analytics, sometimes a decision maker gets so enamored with the visuals that they don't make decisions in a timely way. They wait until the scenario develops, and oftentimes they miss critical tipping points when they should have made a decision but didn't.
Well, I hadn't thought of that. There's analysis, there's the paralysis by analysis, methodology of people in uncertain decision-making environments waiting for the next piece of information to make a decision, so they get to that confidence level. And the more data that's coming in a timely fashion, the more likely they are to delay that decision, right? And so I'd never thought of the role of visualization in making them, spend more time with that. On the sort of the converse I've heard from a couple admirals who sort of have said that, I finally understand what's going on. I've looked at this data and seen these charts and seen these Excel spreadsheets for years about what we're doing, and I could never understand it, that a simple sailor like I can now make sense of this. He's not a simple sailor. It's just that he's got a tiny slice of time to look at this and make a decision. He doesn't have the time of an analyst to spend 2 hours understanding the sources and go through it. And so it's that it can be good, but it can also be very bad that people are interested in just sort of exploring more. There's sort of the engagement piece, right? Which is why people are talking about games for education and scientific discovery. We just had a faculty candidate today who was talking about that. But it's how do you engage people and get them involved and take that time?
Well, let me ask a follow-up question.
Right?
Have you ever thought about doing Pareto analysis of the effectiveness of decision makers based on visual analytics?
We have not gotten to that point, but that would be a great thing to do. And Everett Lindquist, the head of public policy at the University of Victoria, is now trying to get sort of a research agenda of the role of visual analytics into policy. He has given a number of presentations at policy conferences and did a study for the Australian government on how this could be used. And so we're interested. We're now working with someone from the Department of the Treasury to try to get the U.S. involvement in this side of things, because it'd be very interesting to see.
Just one comment from what Arden had brought up too. This is similar to at the Office of Naval Research, where we funded, I call it from a human factors standpoint, understanding visualizations for people that work in like our sonar operators, that visualizations, and trying to see, a small signal in a high noise environment, and what visualization aspects and the flow, very rapid flows of information in sometimes a very fast-moving event where you have to make decisions quickly. What leads to good decisions and what leads to not so good decisions? And a lot of times that is based upon the cognitive science behind visualization. So we supported a lot of work in that over the years.
Yeah. And our team, I mean, we have 25 schools and 85 researchers. We have people in cognitive science. We have people in visual perception. We have people in decision theory, all trying to bring that different expertise together, because then the question is, how do we judge whether we've been effective? How do you evaluate these tools when you're putting them out there and saying, is a law enforcement officer making better decisions based on your tool? It isn't the type of thing where you can do you can do university tests with 50 undergrads, put them in an environment and say, see, this tool's better. And the problem with some of these things is always, if something is discovered from the tool, people take action, an event doesn't occur, was it a huge success, or were you completely wrong and there was no event that was going to occur? The failures are very obvious and very public and very embarrassing when you miss pulling something out and being able to detect that something's going to occur. But if you take preventative action, you never know whether you're right. And so that's one of the things we're grappling with. And there's a lot of theories called, an area called cognition in the wild, that some of our researchers at UCSD developed the whole area. They've got a great book out on it, and we're trying to apply that of how do you do in complicated decision-making environments determine how to make people more effective. So, thank you.
Other questions? Thank you, David.